Good morning, students. Our next topic is operating principle of single phase voltage source inverter. We have two types of single phase voltage source inverters. So first one is single phase half bridge inverter. So just like already we know that a half wave rectifier and full wave rectifier. Same like here also we have a half bridge inverter and a full bridge inverter, two types. Again, in a single phase half bridge inverters, we have three types. So it's mean based on the load, we have again three types. So first one is purely resistive load and resistance and inductive combination load, and RLC overdamped and underdamped. Okay, RLC load, but that one also having two types. One is overdamped and underdamped conditions. Okay, then we'll go for first one is single phase half bridge inverter with purely resistive load. So this is the operation is very simple. So there is no any much more difficulty in this operation and waveforms. It's very simple operation. Basically here we have a T1 and a T2 two thyristors, and the load is resistive load. So that resistive load we can keep in between A and B terminals. So here we can divide the power supply voltage Vs by 2 and Vs by 2. So these two voltages are completely different to this particular load. It's mean the flow of current is completely opposite to a load resistance. Here Is is the flow of current for first half cycle. So you remember here I'm going to tell you here when we can turn on T1 thyristor only and T2 in turn off condition, we are not giving any power supply for this particular loop. Then the flow of current flows from Vs by 2 to T1 and T1 to B to A. Okay, that one is also a first case. So case 1, flow of current direction is Vs by plus Vs by 2 and T1 and B to A. So the flow of current flows through load is B to A. Then that one is minus Vs by 2. Again, it's mean the loop is completed like this. Then this complete loop is in turn off condition, because the T2 in turn on condition. When T1 in turn on condition, T2 in turn off condition. Then again we can turn off this T1 thyristor. Then we can turn on T2 thyristor. Then we are giving power supply for this loop, and we can stop the power supply for this loop in the sense. Then the flow of current flows from A to B. I mean to say that for a load, the flow of current from A to B. So previously the flow of current flows through a load from B to A. So right now the flow of current flows from A to B. That's why these two are completely opposite to each other. If the current flows from B to A, in the sense that one we can consider as a positive half cycle. And then the flow of current flows from A to B, in the sense that one is a negative half cycle we can consider. One more important point here, you remember this one is a purely resistive load. That's why we have taken T1 and T2 thyristors only. No need of any diodes here. So in RL load and RLC load we need a two diodes, because inductor which will not allows the sudden change of current. So that's why that sudden change of current will not allowed by the load, in the sense that sudden change of current will be flows through a loads. Okay, so in some textbooks they have given diodes D1 and D2 diodes, so you don't confuse. For a purely resistive load, if there is a diodes also, there is no any useful. Okay, then we'll go to discuss for a next topic RL load. Then you will understand what is the operation T1 and T2 and D1 and D2 conditions. Okay, So right now for a purely resistive load, if there is a diodes also, there is no any useful of those diodes. So that's why I have to terminated completely that two diodes. Then here we have only two thyristors only in this operation. So here power supply divided into two parts. Each loop is Vs by 2. So already we discussed here. So in this loop Vs by 2 and in this loop also Vs by 2. Then two SCRs are connected in series for switching operation. Switching operation in this is two thyristors we have taken here. Those two thyristors are only useful for switching operation. This purely resistive load, that's why there is no any diodes, already I said. So here we are not showing any commutation circuit or trigger circuit, but T1 trigger on by the T1 TG1 gate pulse and T2 trigger on by the TG2 gate pulse. Okay, when T1 trigger on, supply voltage Vs by 2 acting alone, the current passing through T1 to load. So that load also from B to A direction only. The output voltage is simply plus Vs by 2. Already I said that one. So when a T2 trigger on, at that time T1 in turn off condition, already I said that one also. T2 in turn on condition, T1 in turn off condition, T1 in turn on condition, T2 in turn off condition. Okay, so then the output voltage appears opposite of a previous output voltage, flow of current from A to B. So that's why here the output voltage appears minus Vs by 2. So already I said here, so in this loop the flow of current in this direction, in this loop the flow of current in this direction, these two are completely opposite to each other. That's why here Vs by plus Vs by 2 and here minus Vs by 2. For 0 to T time period and less than or equal to T by 2, the thyristor T1 in conduction mode. So the load is subjected to a voltage Vs by 2. Okay, then the same thing here, during the time period T by 2 is less than, T is less than or equal to T, thyristor T2 conducts and the load is subjected to a voltage minus Vs by 2. So the output voltage is plus Vs by 2, that is equal to I naught R naught, because here we are taking VO voltage. So that VO voltage is simply according to Ohm's law IR. So that's why I naught and R. So I naught in the sense that one is output current. I naught. So that output current, and here load is resistive load now. So that's why I naught into R. Okay. So if for a negative half cycle minus Vs by 2, that equal to I naught R simply. Then we'll go for output waveforms. So before going to discuss about output waveforms, first we need to know about in a purely resistive load condition, what are the magnitudes of voltage and currents. In the sense, voltage and currents both are in same phase only. Already we know that for a purely resistive load, both voltages and currents are in the same phase. So already I have drawn here. So it's mean where voltage waveform started, the same place current also started. Okay, so where output voltage getting a peak voltage, so peak magnitude, the same place current also getting a peak magnitude. Same like for a negative half cycle also, where we are getting a negative peak amplitude of the voltage, and the same place we can get a negative amplitude of the current peak. Okay, so we are getting a peak amplitude at 90 degrees. So for both positive half cycle and negative half cycle, the same operation we are going to discuss in the waveform also here. First one is this one is a inverter now, so that's why we are going to take input voltage is DC input voltage. Okay, so that's why I have drawn here VDC. So that one is direct voltage, and here we have taken IG1 gate and IG2 gate. So it's mean here we have a two thyristors. So first thyristor we are trigger on by using the IG1, and second thyristor we are going to trigger on by using the IG2 gate. Okay, so when IG1 first thyristor in turn on condition, and we can take a first half cycle, the output voltage will be going to maximum at this particular condition. Okay, so that one is a T1 in turn on condition. When it will be going to turn on the IG2 in the sense, so that IG2 is completely opposite of IG1. So it's mean T1 case the flow of current from B to A. So already we know that here Vs by 2, the flow of current from B to A when T1 in turn on condition. It's mean when T1 in turn on condition, in this sense that one is the TG1 gate in turn on condition. Okay, so TG1 gate in turn on condition, the flow of current from B to A. And when TG2 turn on in the sense, then T2 in turn on condition and T1 in turn off condition. At this particular condition, the flow of current from A to B. It's mean the flow of current flows through a load from A to B. So at that particular condition, previous condition compared to previous condition, here right now the flow of current in reverse direction. So that reverse direction means it's a negative. Okay, so that's why here when T1 in turn on condition we are getting positive half cycle, and when T2 in turn on condition we are getting negative half cycle of the voltage. So alternatively it will be going to T1 in turn on condition and T2 in turn on condition and T1 in turn on condition. Okay, the same thing for current also. Here already we discussed both voltages and currents are in the same phase, no? So that's why when T1 in turn on condition, current also we are getting a maximum current for a positive half cycle, and T2 in turn on condition we are getting a negative peak amplitude of the current. So alternatively T1 on in the sense we are getting a positive peak amplitude of the current, and T2 turn on in the sense we are getting a negative peak amplitude of the current. So alternatively, so this is the waveform of the purely resistive load condition. Okay, simply.